Yeah, constraint layout. So I've given a few talks on this before. I'm off to 3 different continents to do the same talk. So hopefully this one will be just as good. This is actually a culmination of 3 talks that I gave in Sydney over the past couple of months. So I've taken 3 15-minute lightning talks, put them all together to make a 45-minute talk, then took out all the duplicate slides from the hellos, the thank yous, any more questions, got it back down to a 15-minute talk again, so then I've had to put in a whole load of more slides. So we'll see how we go on time, but hopefully there's a whole lot of stuff in here that you might not have seen before. So Constraint Layout 2.0. So Constraint Layout, you may have already been using it in your Android apps at the moment. It's been out for a while, but 2.0 was released or announced at Google I/O this year to kind of great fanfare from some of us who've been hearing about it behind the scenes before it was actually released to the public. One of the cool things about Constraint Layout 2.0 is it allows your constraint sets to be defined externally from your constraint layouts. So if you've been using 1.0 at the moment, anybody playing with Constraint Layout at the moment in their Android apps? Yeah, cool, a few people here, excellent, good. So one of the things you'll have at the moment in your layout files is your constraints that define how your widgets relate to each other, buried inside your layout file. So Constraint Layout 2.0 lets you externalize these into a separate file, which is good for 2 reasons. The main one being you don't have to have duplicate XML layout files now between your your start position for your animation and your end position. So what you might find, or what I used to find certainly, was the 2 files would get out of sync very quickly. You'd make a change to a color in one file, forget to copy it over to the other file, and then something crazy would happen. So now you only have to have 1 XML file for your layout, 1 file for your actual constraint sets and the relationships between your different widgets, which is good. Constraint Layout 2.0, the main bit that's been released so far, it's still in alpha at the moment. The main bit that's been released so far is something called MotionLayout. So MotionLayout is an extension to Constraint Layout. So if you want to kind of get started slowly, you want to dip your toe into the water, so to speak, for doing the MotionLayout part, it's a drop-in replacement. You can just kind of change the package name and the class name that you use, and it'll work as is. But then we can start playing around with all the cool new features that MotionLayout brings to allow you to add transitions and movement to your UI more easily. And we'll talk about how you do that today. MotionLayout uses something called a motion scene to kind of capture the transitions between the 2 states and the constraints that are needed to define that, and any keyframes. We'll talk about keyframes as well. And you can also animate custom attributes, so you can have colors changing from one thing to another, and we'll look at that as well today. One other thing in my speaker notes, to transition from your Constraint Layout 1.0 multiple layout files into this new world, there is going to be a tool inside Android Studio. I don't think it's there yet that will let you do the migration, so you don't have to kind of cut and paste and make all these mistakes. You should be able to just highlight, these are my 3 layout files, take all the information and stick it into another file. So that should be a nice thing. Android Studio 3.4 was released into preview maybe a week ago, maybe more, 2 weeks ago, when Android Studio 3.2 went stable. And 3.4 is where there's a whole lot of new motion layout related bits and pieces coming through. So it's good to see that the tooling is now starting to catch up to the library that we've had for a while. One thing I should mention, motion should be meaningful, don't go crazy. I don't know who said it, maybe it was just me just now. But yeah, don't have a banking app with things whizzing around the screen. People kind of get very touchy about their money, and having things whizzing around the screen kind of makes them, it's great for some apps, like a weather app might be cool, but for a banking app, it's like, whoa, what are you doing with my money? So yeah, use it in the right places, don't go mad, don't go crazy. So what do we got? So I talked about motion layout. So on the left-hand side here, we've got like a little diagram. So a motion layout file is just a layout.xml that you would have used already. You've got some views. Helpers are a thing that's coming in Constraint Layout 2.0. They've not been released as of yet. But things like guidelines and barriers, if you've been using those previously, they're kind of the helpers. They're going to be sort of moved into that kind of category later on. And then motion scene on the right-hand side here, this is the other XML file I mentioned. And this is where you can define your constraints, your transitions, keyframes, and all that kind of stuff. So what are those kind of look? And there's a relationship between the 2. So we've got some code here, which is kind of hard to see. Is that too hard to see? Mitchell, you're at the back. Is that readable from all the way over there? So yeah, the main highlight here, so this is a sample layout.xml file, and the important parts here, so you've got your motion layout at the top, defining your, oh, there we go, that's a bit sexy with the lights, cool. And then we have a layout description, which is a reference to the XML file, which contains the motion scene. And for some of the demos that we're doing today in the animations, you can have a flag in there that says show paths equals true, and this will show you the sort of the dotted line of where your widgets are actually going to move during your animations. That's actually really kind of useful. If you've seen the presentation that they did at Google I/O, there's going to be a keyframe editor inside Android Studio where you can edit these things visually, and seeing where the paths are in real time, you can kind of work out where your widgets are going to move during your animation. So you don't have to kind of debug and go through them and put it on a device over and over and over again. You can kind of just visually see straight away what it's going to look like, which is cool. And then here's sort of an example motion scene file, which is stored in the XML res folder of your project. You define some transitions at the top here, which reference the start and end constraint sets. You might have an interpolator in there saying, look, this is going to be a linear one. You can have easing in, easing out, bouncing, all that kind of thing. And then a duration, how long is this sort of transition going to take? And then you can define how that transition is initiated, and we'll talk about that in a second. You can have on swipe or on click. And then also in this file, this is the bit at the bottom, this is where your constraint sets themselves will be defined. And this will be the thing that would have come from your layout.xml files if you've been using ConstraintLayout already. This will be the bit where it says that these two widgets are related via the start or the end, or the top and the bottom. Kind of familiar stuff if you've worked with this before. So transitions allow you to define in the XML file, you can define on swipe and on click, and they work as you would imagine. They're very aptly named. So the on swipe one will register you swiping in a particular direction on a widget and then execute the transition defined. And on click, again, tap on the widget and the animation will kick in. You can define both in the XML file, but if you do define both, the on click one no longer works. So there's kind of this weird kind of relationship going on between the two. And there's a little asterisk there at the bottom. We'll talk more about that later on. And of course, I'm going to only show you the stuff in the XML files today because it's kind of easy to see on the screen and it takes up less space, but you can trigger all these kind of animations and stuff through code programmatically as well. So what does a non-swipe and a non-click look like? So on swipe, again, you have a reference to an anchor. In this one, we've got a text view that we're just going to swipe on, and same with the on click. We're just going to register the click on the text view, and then you defined how the transition is going to be sort of initiated. So you can say I want to be either dragging down or dragging up, dragging left, dragging right, and which is the edge that's going to catch that. So it's a bit weird. You say I'm going to drag up from the top or drag down from the bottom. And then with the on click, you have a mode where you can say, look, I want to toggle between the start and the end constraint set. So if you're in the current start position, it'll move you to the end. If you're in the end, it'll move you back to the start. And then some other ones are transition to end, and then where it'll just go to the end and stay there, and so on and so forth. Jump to start, jump to end. So what do they look like? My first dazzling set of animations today. I realized after doing all of these with Devfest Melbourne as my little text, I'm going to be doing this in another conference with a different name, so I'm going to have to go through and do all my animations again with a different thing on. I should have just put the word constraint layout in there and saved myself about 4 hours work. Anyway, so on the left-hand side, so these are all on click ones. The animations are looped just so you can see them if you missed them the first time. So the jump to the end one, if you were to click on the word Melbourne, Devfest Melbourne, you're just going to jump to the end constraint set, which is put it at the bottom of the screen, and that's it. You try clicking on it again, nothing else is going to happen. It's there forever until you do something with it. Transition to end, and you'll notice that it jumps straight to the end. So you don't see any of the duration, the interpolation, or anything like that. It just goes, take me from the start point to the end point immediately. Done. Transition to end, however, well, the one in the animation in the middle will go through the transition that you have defined, whether it takes 1 second to execute, is it a linear interpolator, all that kind of stuff. So you'll see it go from the top position to the bottom position in a sort of a linear fashion in this particular example. But when it gets to the end, again, it's just going to stay there. If you click on it again, it's not going to move anywhere. It's already in its end state. That's where it's going to stay until you do something programmatically or whatever with it. Toggle, however, the third animation, as you would imagine, you click on it at the top, it goes to the bottom. You click on it when it's at the bottom, it's going to go back to the top. So you've got this way you can kind of play around with moving between two states for free. Exciting animations, I know. So how do we make that a bit more interesting? So keyframes are going to be our friend here. And keyframes, and Nicholas Roord, one of the guys who works on the ConstraintLayout team, he's French, and he defined it as a rendezvous in time, which I thought was quite a nice way of saying what a keyframe is. And obviously rendezvous is French, so it works kind of well. So let's have a look at those. So there's a couple of ways, there's a couple of different types of keyframes you can define. They allow you to define a sort of a transient state between two constraint sets. So they're like a position partway between the start and the end, and you can kind of define some different attributes on them. They're kind of a lightweight version of a constraint set. They're not supposed to hold a whole lot of state. They're literally like a detour. If you're driving from here to Sydney and you want to have a detour, the keyframe is Canberra. You're going to go via Canberra, but you're not going to stop in Canberra, because who would stop in Canberra? And then you make it all the way to, I hope there's nobody here from Canberra. You're going to make it all the way to Sydney. So, so basically they allow you to modify the path that a widget is going to take between the start and the end position of the animation. How do we define one? So we have in our motion scene a particular a section where we can have keyframes listed. Here we have a key position one. There are three parts to it. So frame position 50. So anywhere between 0 and 100, that's the kind of the percentage of the way through the animation that it's going to take effect. So 50 is halfway through. What kind of thing are we going to do with this? So we're going to change the percent Y. So we're going to move the path in the Y direction by a given value. That sits between kind of 0 and 1, or negative 0 and 1 if you want to go in the opposite direction. And a key position type. So how are we going to affect the path? What kind of key position are we doing? There's a couple of different ones of those, and we'll talk about those in a second here. So in the little animation, I've highlighted where the keyframe sits. It's halfway down the screen. And what we've done is we're saying, look, take the Y part of the animation and shift it off to the side. So as we animate from the start to the end, we're taking this little detour on the way down there. So the keen-eyed people in the room might have noticed that I said we were having a %Y keyframe there, and it went kind of left to right, side to side. That is sort of the x-axis in most people's brains, side to side, rather than the y, which is usually up and down. Why is that? Well, it's because of the coordinate system we're using. I'm going to talk about coordinate systems next, because it's important to make sure you get the right one in your head to work out why X and Y work in different directions for different types of animation. You can have different coordinate systems for the different widgets as well. So that's something to bear in mind. You can have things working differently in the same kind of transition as well. So coordinate systems, hopefully this is readable. So there's three different ones. So if you imagine on the left-hand side here, our widget is going to start in its start position and move to its end position. And the parent is the kind of the whole screen in this particular example. A parent relative path type is going to be relative to the whole screen. So you've got 0 to 1, which takes up the entire screen. The third one along is delta relative. So this is going to be a value from 0 to 1, which is a reference between the start and the end position. So it's going to, so halfway there is halfway between the start and the end, whereas the parent one halfway is halfway sort of across the screen. And path relative. So in the previous example, we had a path relative tweak, and that is a coordinate system that is rotated based on the direction that the widget is going to move. So in the fourth example there, the widget's going to start on the bottom left, move to the top right. So this sort of the x-axis is pointing 45 degrees upwards. So you kind of have to turn your brain upside down in some cases to work out what's going on with your coordinate system. So you just need to remember to pick the right coordinate system for the animation that you want to, or the transition you want to have. So let's talk about those. Parent relative. So in this example here, we've got two keyframes. We're going from the top of the screen to the bottom of the screen. All the examples are pretty much the same. Starting at the top and finishing at the bottom with our constraint sets. We've got two keyframes defined here. The first one is 25% of the way through the transition, and because it's parent relative, we've got a %x, which is 0. And then the second animation keyframe is at position 75, and that's %x1, so that's kind of as far right as one can go, and both of those are parent relative. Now you'll notice that the dotted line down the middle, which is the path that the widget is going to take, it doesn't actually touch the edges of the screen, as you might imagine. You know, if you say I want to go from 0 to 1, it's going to go all the way to one edge and then all the way to the other edge of the screen. The actual part that defines where the path is going to go, the path represents the middle of the widget. So if you've got the word Devfest Melbourne, as we have here in this example, it's the E on Melbourne that touches the edge of the screen and the D on Devfest that touches the screen, and that's the bit that kind of defines when it stops and moves back in. So if I have a longer string, those paths are going to be closer to the middle. If I have a shorter string, they're going to be closer to the edge because the actual widget is a smaller widget. So that's just something to remember as well. For the same values of 0 and 1, depending on the size of the widget, you're going to get a different path, but it should still have the bit where it goes to the edge of the screen on both sides. Delta relative, this is an interesting one. So this is relative to the start and the end positions of the actual widget itself. So again, here at 25% of the way through, we've got a keyframe number 1, which has got a %x of 0.75, and at 75% of the way through, we've got a %x of 0.25. Now you'll notice that they've had absolutely no effect whatsoever on the widgets, and that's because the start and the end positions are in the same kind of plane. We haven't moved the start and the end in the x-axis at all from each other. So if we try and change the value of the x-axis, the delta relative is going, well, there is no delta to have. Anything times 0 is still going to be 0. So it doesn't matter what values you put in there, it's still going to go up and down in a straight line. The fun one is if you change the y on a delta. So here we've got keyframe 1, keyframe 2 again, but we're changing the %y. So at 25% of the way through, we're saying you need to be at 75% of the animation. So the keyframe 1 is now actually at the bottom of the screen, whereas previously it was at the top. And conversely, at 75% of the way through the animation, we've said you need to be at 25% of the way down the screen. So keyframe 2 is now at the top. So you get this kind of weird kind of bounce effect. I don't know when you'd use this in an animation or an application, but hey, you can do it. So as we go and transition down, we go all the way to keyframe 1, back up to keyframe 2, and then back down to the end state as well. So a more interesting example for delta is when you start at the top left and finish at the bottom right. In this example here, again, 75% of the way through, we're moving 25% of the way across. So you can see now, because we actually have a delta in the x and the y axis, they take effect. If we have a look at the sort of the direct line that the widget would normally have taken, the green line here, that's if it was a straight line, it would have just gone along the green, but now we're actually pulling it off that green line by a little bit. So yeah, that's delta relative. And then finally, path relative. So did they? Yes, so they all had the coordinate systems on there with x and y working in the way you would expect. Y being the sort of the vertical, x being on the horizontal. But path relative, it depends on the orientation of your transition. So here we've got the widget going from the top of the screen to the bottom of the screen. So if you can imagine kind of your fingers pointing in the direction where the widget's going to go, this is now going to be the sort of the x-axis, and this is now the y rather than kind of horizontal and vertical. So back to our earlier example where we had the y transitioning something in what we thought was the x in our heads, you can see kind of y now, pardon the pun, because the y-axis has changed because we're using a different position type here. So again, you just have to pick the right coordinate system for your animations and everything should be good. One of the other cool things we can animate is not just the position, the path that a widget takes between the start state and the end state. We can change attributes about the widget as well. So we can do things like we change the visibility, the alpha, elevation, rotation, scaling, all this kind of stuff. So we can kind of come up with some really funky bits and pieces. So here we've got a little bit of code that says we're going to rotate the widget 45 degrees halfway through our animation. So that, as you might imagine, looks something like this. So halfway through, we should be at 45 degrees. Again, pretty straightforward. Normally, if you were to try and do this in code, you'd have to do all these kind of scaling things, measure all that kind of stuff. 3 lines of XML, pretty easy. key attributes also let you change custom attributes. So obviously visibility and stuff might be the ones you use on a regular basis, but you can create any custom attribute on your widget if you want. It just has to follow the getter-setter pattern, a get method and a set method for the attribute you want to change. In this example, we've got background color, but you can change integers, padding, things like that, floats, you can change strings, although strings is a bit of a weird one. I spoke to the team about that, and they said, well, we couldn't understand if you were transitioning from hello world to world hello, and you had a key attribute halfway through that said, change it to something else, they weren't going to morph or tween the text, so it's basically a kind of a funny example they came up with it, so they're going to work on that one to kind of come up with something useful. So here we've got the background color changing as a custom attribute on the text thing. So halfway through, we're going to change the thing to red, green, blue. So on the left-hand side here, doesn't match my code from the previous slide, but so we've got a keyframe halfway through the screen that's going to change the attributes. So on the left, we're just going from white, we're transitioning to green in the middle, and at the bottom we're going back to white again. And on the right-hand side, we've defined a custom attribute on our start and end constraint sets. So it starts off red, it finishes in blue, and the keyframe in the middle again is going to transition through the green color. So it'll automatically interpolate the color change for you. Again, go crazy, but not too crazy with this kind of stuff. And you can imagine, changing sizes and paddings and things as well. And we'll see an example of that later on. So let's hope this next animation works. Yes, there we go. Fireworks, time to dazzle. So all my animations were pretty boring, but there's a lot of people out on the web who've done some really cool bits and pieces with MotionLayout. So what I thought I would do is, rather than just copy their work and claim it as my own, we're going to have a look at, we're going to break down two that I see, that I've seen on the web that are kind of good. And because they're open source, we can see how they've achieved what they've achieved, and we can then kind of learn from their examples. So I take no credit for any of this. We're just going to sort of analyze and learn from this. So the first one is an application called TV. It's written by a guy called Chris Baines, who's a Googler. This is his kind of open source project for managing TV shows and stuff like that. And he's changed his kind of TV show details screen to include a sort of a nice little animation as you scroll up and down. Only took him like an evening to convert from ConstraintLayout to MotionLayout and add all this kind of stuff in. So we're going to break down how he achieved that. So the three things that we're going to look at on this screen here, he's got an app bar background, which is the kind of the big green box there. He's got a details poster, which is the highlighted, and a sort of a details subtitle. So we're going to look at what he does to those three components to get the animation that we saw on the previous slide. So we're going to be rather cruel. If we take out all of the keyframes that he added into his layout and just look at the start and the end position, we get obviously a very unfair, rubbish transition. So you can kind of see it starts off here. If we don't do anything with keyframes, things aren't going to transition very nicely, but we get to an end state there. So how are we going to improve this using keyframes to make things better? So the first thing that Chris does is he adds a transition for the position of the poster. So at 20% of the way through the animation, we change the Y, so we move it up faster than the rest of the screen is scrolling. So it kind of accelerates up the screen a bit quicker. The next thing that Chris does is on the details poster, so we have a bit where we're going to do a rotation. So we're going to rotate 45 degrees in one axis, and we're going to rotate 15 degrees in the other axis, so it kind of dips the leading edge of the poster kind of back into the background to kind of swoop behind the header. And he also changes the elevation, so you'll notice now that you don't have the poster kind of half in front of the header and half behind the header, so he's changed the elevation from 4 dp, which is when it's in front, to 0 dp when it's behind. So that kind of gets the bit where it scooches around the edge. And then the final thing he does is around the status, the subtitle. He kind of fades out as we morph towards the top of the screen, and he changes the app bar background so that this kind of horizontal line that we had previously doesn't cut off some of the text. So you can see pretty easily with only 10 or 12 lines of XML, you can kind of get this nice, I'm going to move something out of the way, take it into the background, little animation that kind of adds a little delight to the screen without too much kind of expense in kind of coding and stuff. If you had to do this using the Transition Manager framework previously, that would have been a whole lot of code that you probably would have needed to have written, and it wouldn't have worked quite as nicely, I don't think. So the next example we're going to have a look at is a YouTube demo by a guy called Arman, and he's recreated YouTube using 2 fragments and the MotionLayout stuff. So when I saw how YouTube, the new YouTube app, or not the new now, was working, it's like, oh, crikey, how do I do that? That's pretty impressive stuff, you know, squashing down, moving bits and pieces. Well, we'll see how easy it is to recreate. I don't know if they used MotionLayout in the new YouTube app, but we can recreate it ourselves pretty easily, and we'll see how Arman did it. So, if you can imagine 2 fragments stacked on one on top of the other. The first one we're going to look at here has got a video view at the top, a video view container, and a recycler view underneath, as you would imagine, if you'd used YouTube. And then the one in the background, which is kind of like the list of all the videos, he's got a background dim components there, which takes up most of the screen. We can see the fragment from the previous screen in a minimized state at the bottom there. And we've got a bottom navigation view as well. So those are the bits and pieces we're going to be playing with at the moment. So again, rather cruel. Take out all the keyframes. What would happen if we just looked at the start and the end states and scroll between the two? It's not particularly pretty. It does most of what we want, but yeah, we're going to add some delight to this fairly easily. So what does Arman do first? So he takes the video view and he tweaks the end padding. So he's got a custom attribute here, which is pretty cool. So he can change the end padding so you can see the Batman logo now rather than sticking halfway across the screen. He takes the end padding from 250, he set it up, and at the end of the animation it goes to 0. So we can see that kind of stretching now across the screen because the padding at the end is actually shrinking. So pretty easy. Next thing he does, so we've got a video recycler view at the bottom, which is kind of related YouTube videos if we stick with the thing, and he's changing the alpha on this from 0 to 1. Now, poor Arman. You'll notice here that it doesn't actually change the alpha at all. It's always fully translucent, opaque. And the reason for this is he has obviously changed over time the implementation. He actually has a wrapper around the recycler view. And one of the things to remember or note about constraint layouts and therefore motion layouts is they only affect the direct children of the constraint layout. And because he's now got this nested component, the recycler view inside a wrapper, his animation on the alpha of that component no longer works because it's not a direct child. So one of the things I tried to tweak when I was setting up these slides was how would I go about fixing this. Unfortunately, he uses this wrapping layout around the recycler view to control the size, so he can kind of grow the size more easily over time. So it's a bit more tricky. So obviously he's had to do that for certain reasons, but he's kind of lost out on this alpha thing. It's probably an easy fix, and we can kind of talk about how that fix might come in later on as well. And the final thing he does is he changes the elevation. So this one is quite tricky to see. When I was doing the animations, scrolling a little bit at the bottom, you'll notice there's like a card elevation. So when the view is collapsed, it kind of pops off the screen, kind of sits there and looks like it's floating over the top of the content in the background. But as we start the swipe upwards, it goes into the background and that kind of shadow disappears. Then it kind of takes over and becomes the full screen. So he's got a little card elevation change, again, a custom attribute, and it happens at frame position 3. So literally 3% of the way through, boom, straight into the background. So you see this kind of raised state briefly at the start. And next he is, so here we go. So yes, he's again, another custom attribute. He's changing the bottom navigation view. So as we send the video view into the background and we start to stretch across the screen, we don't go over the top of the bottom navigation bar, we kind of translate it downwards so it kind of animates off the bottom of the screen quite nicely as well. So at the same time as all this is happening, as we're expanding and collapsing, we're fading the background. So this is, I should have mentioned this on the previous slide, so the bottom navigation bar and the background are the fragment behind the video view. So now he's changing the background fragment in relation to how much we've scrolled the foreground one. Again, it's a custom attribute. We're just changing the background color and we're just making it more gray. Pretty straightforward. So to coordinate these two fragments as you're scrolling the one in the foreground and having stuff change relative to it in the background, what he has is a transition listener. So he is synchronizing in code the position of one is now affecting the other. So as you go from 0 to 100% in the foreground, he's passing that value here, just basically passing the progress to the other motion layout, which controls the background fragment, and saying, look, when I'm at 10%, be it 10%, 50, 50, 100, 100. So the animations look like they're nice and sync, which is good. And pretty straightforward. And this is one of the things we could have done as a solution perhaps to the recycler view. We could have had the recycler view inside like a child motion layout and again passed the progress between the two. So as we are expanding the YouTube video, we could say, hey, recycler view, change your alpha from 0 to 100 or 0 to 1. And that would have kind of solved the problem of having the nested child not automatically update. So, in closing, so we can get time for questions, ConstraintLayout 2.0 is still in alpha, but it's based upon ConstraintLayout 1.1, so don't fear it necessarily. Alpha just means that the API can possibly change, but it's not going to maybe have bugs. If you test your code, you can still use it in production if you wanted to. Alpha 2 is the one that's currently available. If you're already using Alpha 1 and you want to update to Alpha 2 with some bug fixes and performance improvements, there is a namespace change to be aware of because there were some clashes between constraint layout and architecture. The navigation components released as part of Jetpack. So navigation changed and constraint layout changed to both move away from just using the word type to a more specific one for their use case. And Android Studio 3.4 should please contain the keyframe editor, which was demoed at Google I/O this year. As I mentioned, it was released in preview recently. I spoke to one of the guys on the team. He's been on paternity leave, so he doesn't know if they've actually shipped that part in the preview or whether it's hidden with like a secret flag. So hopefully we'll know more soon. I mentioned at the start, if you had an on-click and an on-swipe defined in the same motion scene, that the on-click would no longer work. Again, I spoke to one of the team, John Horford, who works on MotionLayout and ConstraintLayout. They hadn't considered it as a potential use case that you'd want both. So I kind of gave them the example of like a bottom navigation bar that you can swipe up to get like a bottom sheet panel in your app, but you might want to have like a little click to dispose. So you'd want to react to both the swipe to animate up, but then click to kind of maybe close it automatically. So that's something that hopefully will come along in Alpha 3 to have the ability to do a swipe and a click on different widgets. And as I mentioned, Nicholas was on paternity leave. He gets back to work on the 5th of November, so Alpha 3 hopefully should be released sometime after the 5th of November, which is good. Some resources, if you want to play around more with ConstraintLayout, and hope you do, in MotionLayout and see all the coolness and add it into your apps. There's a YouTube video from Google I/O this year where they kind of released it to the public. There's some GitHub examples from Google where you can play around with some of these animations. Nicholas Ward, one of the team, did a great series of blog posts on Medium about MotionLayout as well, so I recommend going and reading those. And then the two examples that we went and broke down, Chris Baines' TV app and our man's YouTube demo. Code's open source, you can go and dig in there and see how it is. Who to follow, so if you want to keep up to date with what's going on in the world of MotionLayout, I can't imagine why you wouldn't want to do that. Nicholas Ward and John Horford are on the team that actually builds it, so they're on Twitter as well. Mark Allison, who's a Google developer expert for Android based in the UK, he's done some great blog posts, not just on MotionLayout, but a whole lot of other stuff, but specifically he's done some good ones on MotionLayout. Chris Baines, again, he's done some posts about MotionLayout, specifically around adding it to his TV app. And there's another GDE for Android, a lady called Rebecca Franks. She's done some online YouTube training videos. She's based in South Africa, and she's done some talks as well, so you can find her stuff online. There's a whole load of other people talking about it as well, because it's the new hotness in Android, so jump on board. And with that, thank you very much.